Hey guys, welcome to the 60-second C programming tutorial, and in this tutorial we're going to be looking at the stack. And the stack is just this part of memory where all local variables are stored. So if I go ahead right here and create an integer variable called I, then this integer variable would be stored on the stack. And if I were to create a string, that too would be stored on the stack. So if I say character array my string, this character array right here would be stored on the stack. So now let's just go ahead and take a look at the stack, how it works, and what it actually looks like. So to do that, we're just going to go ahead and do it in Paint so that you can actually visualize what I'm talking about. So first, we just have to draw the bottom of the stack. So I'm going to say that this right here is the bottom of the stack. And that's what I'll go ahead and label it as. Bottom of stack. Alright, so whenever we create a local variable, that variable is pushed or put on top of the stack. So when I create this integer variable called I right here, that integer variable is pushed right on top of the stack. So we'll say that our integer variable is orange, and that value is just pushed right on top of the stack right here. So this is I. Alright? Then, after our local variable I is created, we created this character array called myString. And that is then pushed on top of I. So we'll say that's red, and myString is just right here on top of the stack. So myString. So whenever you create a local variable, it's pushed on top of the stack. It doesn't matter what's previously on the stack, it just pushes that new local variable onto the stack. So let's just go ahead and say that we were to create a short. So we'll say short s equals 2. That would also be pushed on the stack since it's a local variable. So if we go back and Paint right here, we'll just say that it's pushed right on top of the stack. And since a short is only 2 bytes, it'll only take up 2 bytes. So this is our short s. And then we'll just go ahead and create another short, and I'll just call that s1 and set it equal to 7. So then that short variable s1 is just pushed right on top of the stack. So s1 like that. So this right here is our stack frame, or sometimes called the activation record, for our main function. So basically a stack frame or an activation record just shows all of the local variables and what they would look like on the stack. But this, of course, is not actually what a stack looks like in memory. Memory is more like a grid. So let's take a look at what it would actually look like in memory. So let me just go ahead and open up my grid. Alright, so we're just going to go ahead and say that the bottom right hand corner right here is the bottom of the stack. So bottom of stack. Alright, so the first local variable that we create is I. So these 4 bytes right here are just set aside for I. So this is for I. And then our next local variable is myString, and then that's just pushed right on top of the stack. So the next 4 bytes are located for myString. So it looks like B, O, B, and then an alternating character. And then after that, we have 2 short variables, s and s1. So first comes s. So these 2 bytes are for s. And then the next 2 bytes, of course, are for s1. Alright, and even if I don't initialize a variable, so even if I don't set it equal to something, it's still pushed onto the stack. The appropriate amount of memory is still set aside on the stack for that variable. So if I were to go ahead right here and just say car star some string, 4 bytes are still set aside on the stack for this character pointer. So if I go back and Paint right here, yeah, these 4 bytes right here are just set aside for our character pointer called SumString. So SumString, like that. And if we were to just create another uninitialized variable like car C, then 1 byte would be set aside in the stack. This is a pointer, so 4 bytes are set aside. This is just a single character, so only 1 character, 1 byte is set aside on the stack. So then we'll just say that this right here is just for our character variable C. Alright, so now let me just go ahead and prove to you that this is how the stack looks. So right here, we know that S comes right before this string, my string. So this right here is S, and it's 2 bytes long, so this is just 2 bytes right there. So let's just say that we wanted to access my string through this short S right here. Well, what we could do is actually get the address of S and then just add 1 to it. So add the size of a short to that, and that would give us the address of Bob. So if I go ahead right here and say printf, and I'm just trying to print out a string because I'm trying to print out my string, I could say %s and then say the address of S plus 1. Now you're probably wondering why I'm only doing 1 and not 2. Well, remember that when you're doing pointer arithmetic, it actually adds the size of that variable to the address. So a short is 2 bytes long, so when we're adding 1, it's like adding 1 short to it. So a short is 2 bytes in size, so we're just adding 2 bytes to this address right here. And by adding those 2 bytes, or that 1 short, to it, it should give us the address of this string, Bob, right here. Alright, so when I run this, I should just get it onto my screen, Bob. And I do. Perfect. Alright, so that's pretty much it for this tutorial and the stack. There's still a whole lot more to talk about with a stack, but that's pretty much the basics. Alright, so see you guys.